In this screencast, we're going to look at using React in the Office UI Fabric React components. But in this first section, we're going to look at Fabric React or React as a 101 type overview and the basic React web part structure. So we're going to start with React 101, how to create a React-based web part, and then the structure of the basic template. Now, when you build and design React-based web parts, there's a couple of different things you want to think about. You want to think about the component design, you want to think about splitting up your user interface, and then you want to think about designing the different flow and communication of events and properties throughout your web part. So let's look at each one of these things. The key feature of React is composition of components, and components are written by very different people, and they should work very well together. You're going to add functionality to a component without causing rippling changes throughout the entire code base. For example, it should be possible to introduce some local state into a component without changing any of the other components that use it. And similarly, it should be possible to add some initialization and teardown code to any component whenever necessary. Now, there's nothing bad about using state or lifecycle hooks and components. Like any powerful features, though, they should be used in some sort of moderation. And in React, components are going to describe any composable behavior. And this is going to include rendering and lifecycle and state. Now, let's talk about breaking the UI into component hierarchy. The first thing that you're going to want to do is draw boxes around every component and subcomponent in your design and give them all names. If you're working with a designer, they may already have done this, so go talk with them. Their Photoshop layer names may end up being the names of your React components. But how do you know what should be its own component? And just use the same techniques for deciding if you should create a new function or new object. One such technique is going to be where a component should ideally only do one thing. That's called single responsibility. And if it ends up growing, it should be decomposed into smaller subcomponents. Since you're often displaying a JSON data model to a user, you're going to find that if your model was built correctly, your UI, and therefore your component structure, is going to map quite nicely. That's because the UI and data models tend to adhere to the same informational architecture, or IA, which means that the work of separating your UI into components is often very trivial. Just break it up into components that represent exactly one piece of your data model. So you're going to see here in this little diagram I have off to the left, you're going to see I've got 5 different components in my sample application. And I've italicized each of the different data components they're going to represent. So the filter product data table, which is showing up here in orange, is going to contain the entirety of the entire example. That's my top level component. I've got a search bar which receives all user input, a product table that's going to display and filter the data collection based on the user input, a product category row which is going to display a heading for each category. I've got a product row which is also going to display a row for each one of the different products. Now, if you look at this product table, you're going to see that the table header that contains the name and the price labels isn't in its own component. This is just a matter of preference. There's an argument to be made either way. But in this example, we left it as a part of the product table because it's part of the rendering of the data collection, which is the product table's responsibility. However, this header grows to be complex. So if we did things like sorting or filtering, it may make sense to make this its own product table header component. Now that I've identified the components in my little sample application, I'm going to arrange them into a hierarchy. That's going to be easy because components that appear within another component in the sample application should appear as a child in the hierarchy as you see here. Now that you've got your component hierarchy, it's time to start implementing your app. Now, the easiest way to do this is to build a version that takes your data model and renders the UI, but it has no interactivity. It's best to decouple these processes because building a static version requires a lot of typing and no thinking, and adding interactivity requires a lot of thinking, but not a lot of typing. You're going to see why. To build a static version of your app that renders your data model, you're going to want to build components that reuse other components and pass data using properties, or props. These are a way of passing data from a parent to a child component. And if you're familiar with the concept of state, you're not going to use state at all in this static version. State is reserved only for interactivity, and that is data that's going to change over time. Since this is a static version of the app, we don't need it and we don't want to add it in just yet. You can build a top-down or a bottom-up. That is, you can either start by building the components higher up in the hierarchy, so just starting with the filterable product table, or with lower ones like a product row. In simpler examples, it's usually easier to go top-down, and on larger products, it may be easier to go bottom-up and write tests as you build. At the end of this step, you're going to have a library of reusable components that render your data model. The components will have only the render methods since this is a static version of your app. The component at the top of the hierarchy will take your data model as a property. If you make a change to the underlying data model and call the React DOM.render method again, the UI is going to get updated. And it's easy to see how your UI is updated and where to make the changes since there's nothing complicated that's going on. React's one-way data flow, also called one-way data binding, keeps everything modular and very fast. Now, to make your UI interactive, you're going to need to be able to trigger changes on your underlying data model. And this is going to React's going to make this really easy using state. To build your app correctly, you first need to think of the minimal set of mutable state that your app needs. Here, the key here is the dry concept. It's don't repeat yourself. Figure out the absolute minimum representation of the state your application needs and compute everything else you need on demand. For example, if you're building a to-do list, just keep an array of the to-do items around. Don't keep a separate state variable for the count. Instead, you're going to want to render the to-do, when you want to render the to-do count, simply take the length of the to-do items array. Think of all the pieces of data in your example application. We've got an original list of products. We have the search text the users entered, the value of the checkbox, and the filtered list of products. So let's go through each one of those and figure out which one is state, and simply ask three questions about each piece of data. Is it passed from a parent via properties? If so, it's probably not state. Does it remain unchanged over time? If so, it's probably not state again. Can you compute it based on any other state or properties in your component? And if you can, that's not state either. The original list of products is passed in as a property or as props. So that's not state. The search text and the checkbox, they seem to be state because they change over time and they can't be computed from anything. And finally, the filtered list of products isn't state because it can be computed by combining the original list of products with the search text and the value of the checkbox. So finally, I think that our state is going to be the search text the user has entered and the value of the checkbox. Okay, so I've identified the minimal set of app state that we're going to have. Next, we need to identify which component is going to mutate or is going to own this state. Remember that React is all about one-way data flow down the component hierarchy. It may not be immediately clear which component should own what state. This is often the most challenging part for newcomers to understand, so follow these steps to figure it out. For each piece of state in your application, you're going to want to identify every component that renders something based on that state. You're going to find a common owner component, such as a single component above all the components that need the state in the hierarchy. Either the common owner or another component higher up in the hierarchy should own the state. If you can't find a component where it makes sense to own the state, create a new one simply for holding the state and add it somewhere in the hierarchy above the common owner component. Now that we've done that, let's run through this strategy for our application. The product table needs to filter the product list based on the state, and the search bar needs to display the search text and check state. The common owner component is the filterable product table. It conceptually makes sense for the filter text and checked value to live inside of this component. So we've decided that our state lives in the filterable product table. First, let's add an instance property. This state equals filter text is nothing, in stock only is set to false. We're going to add that to the filterable tables constructor to reflect the initial state of our application. And then I'm going to pass the filter text and in stock only to the product table and search bar as a property. Finally, I'm going to use these properties to filter the rows in the product table and set the values of the form fields in the search bar. And you can start seeing how the application is going to behave. If I set filter text to ball and refresh the app, you're going to see the data table is going to be updated correctly. Now, so far, I've built an app that renders correctly as a function of props and state flowing down the hierarchy, but now it's time to support data flowing the other way. The form components deep in the hierarchy need to update the state. Now, React makes this data flow explicit to make it easy to understand how your program works, but it does require a little more typing than traditional two-way data binding. If you try to type or check the box in the current version of the example, you're going to see that React is going to ignore your input. This is intentional, as we've set the value prop of the input to always be equal to the state that's passed in from the filterable product table. Let's think about what we want to have happen. We want to make sure that whatever or whenever the user changes the form, we update the state to reflect the user input. Now, since components should only update their own state, the filterable product table will pass a callback to the search bar that will fire whenever the state should be updated. We can use the onChanged event on the inputs to be notified of it. And the callback passed to the filterable product table will call setState. And then the app will be updated. Sounds complex? It really is just a few lines of code. And it's really explicit how your data is flowing through the app. So how are we going to create our React web part? You're going to create a new React web part by running the SharePoint Framework's Yeoman generator as yo@Microsoft/SharePoint. And after you say you want to create a web part, it's going to ask you what kind of web framework you want to use. You're going to pick React. So let's take a look at the structure of what a React project looks like. A SharePoint Framework web part is the same as a non-React web part. You're going to see that we have, inside of our web parts folder, we have a React web part demo, and then we have a little bit farther down, you have our React web part demo webpart.ts file. The web parts render method creates an instance of a React control and then adds that to the page. The React control, or the component, is located in the components subfolder in a TSX file. The TSX file stands for a TypeScript extended, and it's a variation of the JavaScript extended language, which allows us to do JavaScript and HTML markup all together inside of one string. It treats the markup as code, and we don't have to escape it in a string like we would normally do if it was a JavaScript or a TypeScript file. So we can see we've got our React web part demo.txx. That is our React component that we've created. This is going to be best understood if we can actually go ahead and create one. So let's switch over to a demo and see how we can build, bundle, package, deploy, and install a React-based SharePoint Framework web part. In this exercise or demonstration, we're going to create a SharePoint Framework client-side web part that's going to leverage the React Web Framework. So I'm going to start by first creating a new folder where I want to create my project. And I'm going to go ahead and navigate into that folder. Now I'm going to go ahead and run the SharePoint Yeoman generator. Now this is going to be a standard SharePoint Framework web part, nothing special about this. So I'm just going to choose most of the default options here that are being provided to me or prompting me. And here I'm going to choose, I want to do a web part, and we're going to call it our React web part demo. And then for a web framework, I'm going to go ahead and choose React. So now the Yeoman SharePoint generator has gone ahead and is provisioning my all the files and the folders. And then it's going to go ahead and run npm install and download all the dependencies. So through the magic of video editing, we're going to go ahead and skip through this npm install so that you don't have to wait for this. All right, now that the project has been created, let's go ahead and see this guy run. So I'm going to jump back over here to my command prompt and just do a gulp serve. And let's see this run in our local workbench. So once the workbench loads, we're going to go ahead and select our web part. And there we go. We see our web part up and running. So everything looks good. Let's go take a look at the actual code base though, and let's see what was added to our project. So first, if I come over here to our code, let's first look at package.json. And what you're going to see here is that I've got all of the types that have been added, or the dependencies that have been added for working with React. I've got the React library and the React DOM library. And the way these work is that React is the actual React engine, whereas React DOM is the bridge between the React engine and the browser DOM. We do also have two separate TypeScript type declaration libraries as well to make it easier for working with React files. So that's everything we're going to need to work with React. Now, if I come over here and look at the actual project, if I look at the web part itself, you're going to see this looks a little bit different from a normal web part. And the real important part here is just the part that I have highlighted. What you see here is inside the render method, what we're ultimately doing is we're going to call React DOM.render and then pass in a React element and the HTML element where we want React to render our component into. So this element here, we're going to look at that in just a minute. This DOM element, that is the div that is on the page that the SharePoint Framework has added to the page where my web part should be rendered. So here what I'm doing is I'm creating an instance of a React element. I'm telling it what element do I want to create. That's our React web part demo. We'll look at that in just a minute. And then I'm passing in or setting all of the public properties for this. So this would effectively be the same thing as if I came over here and I said something like this.dom element, and I said React web part demo, and then description equals, and then if I did, and I data bound the value of this control like this. If I then data bound the value of the description property from right here. So this is doing it more the programmatic way. This is doing it more of a declarative way. We're going to leave it the way it is by default. Now notice here that I said we were loading in this component from the React web part demo. That's being defined right up here. So if I come over here and look in components, you'll see my React web part demo. One thing you'll notice that's different is this TXX file. TSX stands for TypeScript and Extended. And what this allows us to do is to have markup be right in line with the code. So you see here that this markup is not being escaped in a string or written out as a string like we're used to doing when we don't work with a JavaScript framework. So here we can see we're creating a new class called React Web Part Demo. It's extending a React component that has a set of properties that are defined and a state that's defined. Now we're going to get to the state and properties in a later section inside this screencast. But here you can see I'm just rendering out all the stuff related to my the rendering that I want to use. There's a couple things you may notice here that are a little bit different from traditional HTML. Notice that the div has a class name attribute and not a class attribute. And the reason for this is because the word class is a real reserved word in JavaScript and TypeScript. So React had to come up with something different. They chose class name, and this will actually be translated down to class when everything is rendered out. You also notice that we have the way our styles are done, or way the data binding is being done, is things are not quoted. I'm just putting things based on whatever the value is. So in this case, styles.container, .row, .column. We can even see here when I'm writing out some of the description here, how things are being written out as well. So it looks a little bit different, but it should be pretty familiar because it looks very similar to what we're used to doing. All right, so let's go ahead and let's make some changes to this. Let's go over to our web part and let's create a new interface here. So I'm going to create a new interface, and we're going to call this the iColor interface. So what is a color object? Well, it has a number associated with it, and it has a title associated with it as well. Now the next thing I'm going to do is I'm going to create a new React component that's going to show a list of all the colors that are provided to it. So I'm going to come over here into my components folder, and we're going to create a new file here called colorlist.tsx. And inside this we need to import React from React. It's not spelled right. React. We also need to import iColor from some interface that we're going to have to define. So we didn't create the interface. We need to go create that interface though in just a second. So that's going to be inside of iColor. And let's go fix that right now actually. So I put this iColor over here. Let's take this color interface like this, and we put that, let's put that in the root. So we'll do iColor TS. And I copied the wrong file, the wrong line. Where is this? We want that. And we'll put that right here. All right, so there's our color, and it's no longer inside this file, so we're good. So here's our color list. So we're importing it straight from iColor. iColor. There we go. So we had our quotes off. All right, and that's all fixed up. So now let's create a new, define the public interface or the public signature of this component. And I do that by creating an interface. So I'm going to create my interface of iColor list props. And I'm going to just return back, say this is my colors, iColor, like that. Now, let's create our React component. So I'm going to export a new class. This is a color list that's going to extend the React.component. And I'm going to pass in our public properties and an empty state. We're going to deal with state later in this screencast. And this is going to have a single method, public render, that is React element, right? Because this is the thing that we were just creating just a second ago. And this is going to return back nothing for right now. Okay, now, so our render method looks pretty good here. So we got our default setup here for our color list. So what I'm going to do now is we're going to update the render method so that inside this return statement, we're going to do something a little more interesting with this. Instead, what we're going to do is I'm going to create an unordered list that is going to take this, all the colors that are passed in. So this is being mapped to our public property you have up here, all the colors that are being passed in, and we're going to use a map function to look at the color item and say, create a list item for each one of these colors. All right, so now we've got our color list component is all set up now. Now with the React component created, that's going to display a list of colors. The next step is to use it. So I'm going to do that by updating the default React component that was created by the SharePoint Framework Yeoman generator. So what I'm going to do now is come back over here to my TSX file, and I need to import a few things. I'm going to have to import, we're going to have to import our color interface, and we're also going to have to import our color list component and the interface associated with it as well. Now, let's create a new private member inside of this guy that's going to contain a list of colors. And this is pretty simple. We're just going to have an ID for the first one of 1, and the title for this is going to be red. And we're going to need to do 2 more of these. So we will have ID of 3 and 2. So then we'll have blue and green. There we go. So now I want to update the render method for this guy. Oh, we're getting a build error. Let's just take a quick peek here. There we go. We just hadn't saved this file yet, so no, that's all fixed. So let's come back over here. And now inside of our render method, let's update the render method to, let's start right about here. Let's get rid of all that. So after this span, we have welcome to SharePoint, and let's change to SharePoint and React. And then let's add in our color list. So I'm going to have a color list control that has a set of colors, and we're going to map those colors, not class, colors. That's our public property we define, and I'm going to set those colors that I had just added to it. So there we go. We've added in our color list component. So now let's test everything out. So I should be able to go back to my browser, and I should see, yep, there we go. Everything is now rendered because gulp serve was still running in the background, and it was building everything in the background and making sure that everything continued to work. So here you've seen how to create a React component and how to leverage it inside of a SharePoint Framework web part. You're also seeing how to take properties and to bind them in. So we saw how to create this collection right here. So remember, right now we're in here's our web part. We didn't do anything to the web part itself. It's still loading in this React component. That React component now has a collection of colors. And then all we did was we said, let's use that color list component that we created. And that color list component, all he does is he has a public interface here that shows a list of colors. And then he's just going to enumerate through all those colors and write them out as list items. So in future demos, what you're going to see is how we can take advantage of this and make it a little bit more interesting, make it a little more dynamic, make it a little more reactive, and also to make it look a little bit better using the Office UI Fabric and Fabric React. In the last section, we talked about React from a high level and then how we can leverage it inside of a SharePoint Framework web part. Now let's see how we can use React in the Office UI Fabric React components. We're going to first start by talking about the Office UI Fabric and then Fabric React. And then we're going to see how we can add Fabric React to a SharePoint Framework project. So what is the Office UI Fabric? The Office UI Fabric is built by Microsoft. And the idea is that it's a UI design language that is used across all of the Microsoft Office suite. So you'll find that in Office, like the Office clients such as Outlook, Word, Excel, PowerPoint. You're going to find it inside of Office 365, like Exchange Online, Outlook, SharePoint, Planner, Microsoft Teams, etc. Now, the Office UI Fabric is all about styling. It's all about styling and colors and typography. It also integrates really well with other frameworks and is available to you for use inside of your custom components. It's consisted of a bunch of CSS classes primarily. This project is open source. It's developed and maintained by Microsoft in order to help the developer community build Office add-ins and Office 365 based web applications that will integrate seamlessly with Office. They also provide a point of reference for the evolving Office 365 design language that anybody can reference. It enables the community to contribute to a better experience for everyone who builds for Office. If you think about it, if you're working inside, you're building a custom SharePoint Framework web part, wouldn't you like your web part to look and behave like the rest of the application it's running in so that developers don't have to worry about training your end users? I want it to look and feel like it's part of SharePoint, not like it's something that I built. Now, Microsoft releases changes to the design language, components, and other assets quite frequently, and this is going to make they make these updates available to the community. If features are deprecated, Microsoft notes those in a changelog, and the feature will also be removed from the next major release after it's been deprecated. So I've got some links here where you can learn more about the changelog and how you contribute to the GitHub repository for the Office UI Fabric. So let's talk a little bit about styling. Some of the things that it covers are fonts and typography. So it's got the standard Office Segoe font family, a type ramp, and the official Office 365 iconography as custom fonts. The colors are going to match the Office 365 color palette. And then we've also had branded assets. We have things like product file type symbols, product symbols, etc. There's even some animations. And like the official ones that Office 365 uses for easing and other animations that they leverage. And in addition, it also has a responsive grid that is tailored to the Office 365 silhouette. The Office UI Fabric provides styles to allow you to implement the following things in your application. As I've talked about already, we have typography, color, icons, animations, a responsive grid, and there's even some localization stuff built in. As far as the typography goes, these are base font classes that are available to us. Fabric includes 10 base font classes that represent the type ramp for Office design language. Each base class sets a default size, weight, and color. There are also some helper font classes, so you can use one of the several helper font classes to change the text weight. For colors, there are 9 themed colors and 11 neutral colors. Each has helper classes for text, border, background, and hover states. And they include color classes that are going to act as hooks in the Office 365 suite-wide theming system. When a theming system is applied and to your app or your add-in is consuming the suite navigation, these classes are going to pick up the user's chosen theme, and your application can be themed just like the rest of the hosting application. So my web part isn't always blue. It'll be, if the theme for my SharePoint site is blue, it'll be blue. If it's yellow, it'll be yellow. So the colors that the Office UI Fabric gives us are the different theme colors, and it provides a way for doing things like wayfinding and navigation. It also has key indications or in interactions like primary actions and current or selected indicators. The neutral colors include things like black, gray, and different shades of gray, and white. Use darker shades of gray for primary content such as text and tiles. Use black sparingly for high-impact strings like labels and names and hover states. Use lighter shades of gray for supporting graphic elements and page areas. We also have accent colors, which is going to be used for alerts and warnings and informational things. Now, when it comes to icons, Fabric uses a custom font for its iconography. Font contains glyphs that you can scale, color, and style in any way, and you can even flip them for right-to-left localization. To use the icons, you're going to combine the base MS icon class with a modifier class for the specific icon. Note the ARIA hidden attribute, which prevents screen readers from reading the icon itself. In cases where the meaning is conveyed only through the icon, such as an icon-only navigation bar, be sure to apply an ARIA label to the button for accessibility reasons. Now, when it comes to side panel animations, when you're going to choose a motion for side panels, consider the origin of the triggering element. Use motion to create a link between the action and the resulting UI. For example, if a triggering element is on the right side of the interface, consider having the panel move in from the right side. For dialogue animations, when choosing motion for dialogues, consider the origin and the tone of the content. For a warning or an error dialogue, quick fade in might be appropriate. But if the dialogue appears when a user chooses an item to get more information, a scale up may be more appropriate. Now, Office UI Fabric comes with a mobile-first 12-column responsive grid that you can use to create flexible layouts for a variety of screen sizes and device types. As far as localization goes, we have right-to-left support, in addition to the default left to right. Fabric comes with an alternate CSS file for pages written in right-to-left languages such as Arabic and Hebrew. This reverses the order of the columns in the responsive grid, making it easy to create an RTL layout without having to write additional templates. Future versions of Fabric will also reverse some icons and provide additional helper utilities. We also have language-optimized fonts. By default, Fabric presents all text in the Western European character set for Segoe UI. For languages with other characters, Fabric will either serve a version of Segoe UI with a different character set or use a system font. Fabric supports many language codes which utilize different font stacks. Now that we've talked about Office UI Fabric, let's talk about something else called Fabric React. Fabric's components make up the building blocks of your UI that can be consumed as CSS applied to your markup. All JavaScript is presented into a natural behavior, or it explained a natural behavior. And you can download these components from the GitHub repository. Now, the way that this works is that there are some default controls that are provided and used inside of Office 365, like drop-down controls, tables, buttons, toggle controls, text boxes, etc. What Microsoft has done is they've taken the Office UI Fabric, which is just a bunch of CSS, and they've used React to build components that we can then reuse inside of our application so that our application has the same look and feel like the hosting applications such as SharePoint. You can learn more about the Office UI Fabric if you go to developer.microsoft.com/fabric. There's a getting started link that you see here, as well as an open source GitHub repository that you can dive into if you go to Office UI Fabric React inside of the Office Dev organization in GitHub. Now, how do we go about adding Fabric React to our SharePoint Framework project? SharePoint Framework projects include a special NPM package of the Office UI Fabric core for SharePoint. Office UI Fabric core is just CSS. Now, Fabric React, which are the controls, already includes the Office UI Fabric CSS, so we need to remove the duplicate. So I'm going to do that by doing an npm uninstall at Microsoft/sp Office UI Fabric core and save my changes. I'm then going to update the included web parts reference to the Office UI Fabric CSS. I'm going to remove the old reference to the Office UI Fabric Core CSS. I'm going to change the first line in the web parts SAS file from what you see here to the one that's inside of the Office UI Fabric React package instead. So how do we use the controls? You're not going to, I don't recommend that you import the entire Fabric React library. Instead, you only want to import the control that you're using. So in this case here, I'm doing a deep reference down to the list control and importing that into my web part. Then to leverage the control within my React control, I'm then going to say inside the render method, I'll just add the list control and then specify all of its public properties. So let's see a demo about how to work with the Fabric React controls. In this demo, we're going to update the existing React-based SharePoint Framework web part that we created in the previous demo to leverage a few controls from the Fabric React suite of controls. So the first thing that we're going to need to do is we're going to have to update our project to follow the recommended guidance from Microsoft when using Fabric React, which involves doing two things. One is removing the reference to Fabric Core, the Fabric Core package, and then also changing the existing SAS reference. So if I come over here into my project and I look at package.json, you're going to see a reference to the @Microsoft/SP Office UI Fabric Core. So the first thing I want to do is I want to remove this from the project. So I'm going to come over here, go to my command prompt, and I'm going to do an npm uninstall this package and then just save my changes. All right, so now once that's done, you now see that that is now gone from my package. Now the next thing I need to do is go into my SAS file of my project, and instead of using this CSS core file that's coming from the Office UI Fabric Core library, I'm going to change this up and use a different one. So instead, I'm going to point to the Office UI Fabric React /dist/SAS/references.scss. And you can see that when you come up here into the node modules, if you scroll down to the Office UI Fabric, here's Office UI Fabric React, and under dist, under SAS, you'll see our references file right here. So that's the path that I was going to. This is the copy of Office UI Fabric CSS that is included with Fabric React. Okay, so we've got that all set up. And yes, we want to save our changes. Now, the next thing I'm going to do is I'm going to update the existing color list control or component that I created to use the Fabric React controls. So what I'm going to do first is I'm going to add in a couple import statements. Now I want to go use the list control and the default button control. So I'm going to create an import statement, and I'm going to add a reference to the Office UI Fabric React /lib/list, and this is going to give me the list component. And I'm going to do the same thing, but for the button. And instead for the button control, we're going to use the default button. All right, now let's update the control to use these things. So I'm going to come down here and instead of in my render method, let's now come in and let's use the list control. I'm going to set the items equal to the items list control to this.props.colors. And then I'm also going to set the on render cell. I'm going to set that equal to this._on render cell, or on render list cell. That's the name of the method I'm going to use. All right, now what I need to do is a couple things here. I need to create a new method here called on render list cell, and this method is going to have a couple parameters passed in. It's going to have a color passed in. It's going to have an index passed in, which is going to be either an index number or an undefined. And this is going to return back a JSX element. Okay. Now, what this means is that I need to define what's going to show up inside of each element in the list. So what I'm going to do is I'm going to write out the actual color, and then on a break line immediately after it, I'm going to include a button, and the text for this button is going to say delete. The data for the button is going to be bound to the current color we're on, his ID property, and then the on-click event is going to be bound to say that whenever this is called, I want to call this underscore on button click color. All right, and then we'll just close out the button. And in fact, this needs to return back an element, so I need to put this inside of a return, and then we need to wrap everything in a div because you can't have things everything's got to be wrapped in stuff. There we go. So that's all good. Now the last thing I need to do here is I need to create my handler for this on button click. So we'll come down here and say private on button click. When a color is passed in, it's of type iColor. And all we're going to do in this case here is I'm just going to write out to the console, clicked, delete for color, and pass in the object like that. All right, so let's see this work. So let's come back over here to my command prompt. Let's do a gulp serve to build, bundle, and spin up my local web server and add this to the page and see our new controls. Now the workbench is loaded. Let's add our web part. And sure enough, there we can see our list control is working. We have our buttons that are showing up. And if I open up the console, let's clear this out so we can see what's going on a little bit easier. And if I click delete, then we should see, there we go, delete. There's for the red button, the blue button, and the green button. So fantastic. We now have we're using some controls from Fabric React. So we're in good shape now. So in the next sample we're going to look at, or the next section, we're going to start to look at properties and state and making our application a bit more reactive and a bit more reactionary to work with. In this last section, let's extend the existing web part that we've been working with to be a little more dynamic. We're going to look at how to work with component properties, component state, and then how to notify the component's consumers of changes via events. React components are very dynamic. We've got two separate things. We talked about them in the first section, but let's go into a little more depth. Properties are public settings that we have on the components. These are similar to HTML element attributes. We're going to use these to provide values into the component as well as publish events to consumers of the component. And they're going to be defined on the component via TypeScript interfaces. The state of a component is a very special property bag. React is going to detect when the state changes, and it's going to trigger a re-rendering of the component that you're currently in. You're going to change the state using the component's method setState. This is going to be defined on the component via TypeScript interfaces as well. So let's look at component properties. Here I have something called the colored list component. You can see in the middle there where I have a class called color list that extends the React component. So how does this work? Well, I'm going to be passing in some colors, and you can see where I've defined a list of the public properties this component supports by, at the very top, I have an interface called the iColorList props. You see I have a colors collection. It's an array of colors, of iColors. And you can see I specified that as the first of two parameters when I create an instance of the component, or at least when I define it. Within the render method, I'm going to look at the current properties for the component by saying this.props, and I know that he has a property or a collection called colors. So all I'm doing here is just writing out a list of all the colors. Then to consume this component, the way I would use it is I would say color list, and then have my colors attribute, and I'd specify an array of colors. I can also use those properties to publish events. So here I'm creating a new type called the remove color callback, and that's going to pass a single value or parameter when it's raised of a color object. Here I've then gone into my interface, the iColorList props, and created a new property called onRemoveColor that's of type that callback that I just defined. So here you can see that now I've changed my component to now have buttons. It's going to list out all the different colors. But when I click the button, I want it to raise an event on my component called onButtonColor or onButtonClick and pass in the current color that I'm on. The method onButtonClick tapes the color in and is going to call onRemoveColor, whatever has been hooked up to that. So then down here at the very bottom, you can see where I'm using this component of color list. I've created a new handler for the onRemoveColor event that says go run the function _removeColor. That's on the where my current component is being consumed. So let's talk about state. In this case here for state, let's define all the different properties for my state. So I've got a new state that's defined at the top, an interface, that is also a collection of colors. And I'm going to add that as the second parameter for when I'm creating an instance of, or I'm defining the declaration for my class of the React web part. Here you can see in the constructor that I'm setting the state equal to an empty collection of colors. In my render method, what I'm going to do is I'm simply going to say to remove the color. So my colors are set to the current state of an array of all those different colors. When I want to go through and remove a color, I'm then going to handle that by passing in that function to say onRemoveColor, passing in a reference to the method that's going to define the color that I want to remove, which is going to be the current color that we're on. I'm then going to then say, go change the state by creating a new collection of colors that is all colors that we had previously except for the one that we just removed. And then I'm going to set the state equal to this new collection that we just created. Understanding state, how we do properties, and then lifting the state up through the use of events is best understood through a demo. So let's jump into a demo. Now, in this last demo, we're going to update our existing SharePoint Framework, React-based SharePoint Framework web part and make it more dynamic by introducing state and making things more data-driven by pulling data from a SharePoint list. So one of the first things that I've done is I've gone ahead and I've created a SharePoint list in a SharePoint online site. And we're going to start testing our application using the hosted workbench to be able to use the data here that we have inside of this list called colors. So one of the things I'm going to need to do is I need to update the web part to provide additional inputs to our React component. So I'm going to come over here to my web part. I'm going to come over here to my web part, and inside of the render method, we're going to do a little more stuff here. I'm going to update the code that creates an instance of the React component, and this code's going to add 2 additional properties to the web part. So I'm going to pass into this the SPHTTP client, which is this.context.sphp client, and I'm also going to pass in the current site URL, which is on the page context.web.absolute URL. Now, both of these are going to throw an error here in the builds because these are not properties that are exposed or expected to be public properties on this React control here. So let's go fix that. I'm going to come over here to our props, and in our props, need to first go through and import the class or the object for the SPHTTP client. So I'm going to import from @Microsoft/SPHTTP and go to the HTTP client. And then I'm going to have a property called SPHTTP client. And we're also going to have another property called the current site URL, which is of type string as well. Now, we're also going to need to go through and create a new interface that is going to, we're also going to have to create a new interface here. And what our interface is going to do, now I need to go update our, now I need to go update our properties to have these additional, I already did that. Now I'm going to add a new interface to represent our component state. So inside of our components folder, I'm going to create a new file here called the iReact web part demo props, but this is actually going to be demo state.ts file. So here we're going to have export an interface for the state. And this state is going to also have a bunch of colors. So I'll do an import iColor from iColor. Like that. So then I have colors iColor with an array like this. All right, now I want to update our component. So let's come over here to our color list component. And I'm going to add an additional type right after our existing import statement. So I'm going to have an export a new type for remove color callback, which is of type color, or it's going to pass in a color and then just say void like this. All right. Now inside of our properties for our color list component, we're going to have a method called onRemoveColor, which is of type remove color callback. Okay, so all this does is this just created a new callback type that we're going to call whenever someone says they want to delete one of our colors. So what I'm going to do is come down here into the on button click event, and we're simply just going to remove everything you see here and say instead this.prompts. Whenever someone clicks, or on click event here, whenever someone clicks this button, we're simply going to call our new onRemoveColor method. That's our public property listed up here, and we're going to pass back the color that we're currently on. So that way we're going to pass the color back. Now let's go through and let's update the consumer component that's consuming our color list. So what's special about this one is that he's going to need, like you see, we're getting this error here, and the reason why is because we haven't defined the handler for this required property here. So we're going to need to do a bunch of changes to this first. We're going to need to do some changes to go get data, and then how we're going to deal with things when items are actually deleted. So the first thing we'll do is up in the import statement section, I'm first going to import the iReact web part demo state. So this is our iReact demo state. And then I'm also going to need to import from the at Microsoft SPHT. So I'm going to need to import from the Microsoft SPHTTP. I'm going to use the SPHTTP client and the SPHTTP client response. All right. Now, we're going to use both of these. Now, what I'm going to need to do now is I'm going to need to, let's locate the class definition right here. We see this. I'm going to need to use our demo state, specify that as the second parameter being passed in. So I'm going to pass that in like this. Then, after that, I'm then going to come down a little bit farther, and in the constructor for this, I'm going to have a constructor set up, and it's in where the properties be passed in. What I need to do in the constructor is I need to initialize the state. So I'm going to do that by, we're going to have properties passed in, just like this. We need to say, call the super constructor of this. And then I also need to say that this state is going to be equal to colors is empty. We're going to initialize this in just a minute. So this should be props, like that. Now, because this exercise is, or this screencast is about working with React and Fabric React, I'm not going to focus too much on the data access part of the SharePoint REST API. So to keep things simple, I'm just going to copy and paste this method in. And what this does is that this is a method that says get colors from a SharePoint list, and it's going to use the SharePoint HTTP client that's being passed in, and it's going to call the colors list to get a list of all the colors and return those back to, return an array back of all of those colors. All right. So I didn't need to I don't want to focus too much on this inside of this section here. You can go look at the code if you're interested in seeing exactly how it works. Now, what I do want to do is that when this component was loaded by React, the next thing I want to do is in the life cycle before things are rendered, I want to go get that data and add it to the state. So the way you do that is you create a public method called component did mount. And did mount is kind of like on init. So I'm going to say, what happens in here? Well, I'm going to go call this get colors from the SharePoint list. And when I get that data back, I know the data I get back is an SP list item colors collection, which is of type iColor. And I'm going to say this set state, I'm going to set the state equal to an object, which is colors, SP list item colors. All right. So effectively what I've now done is that when the component loads, he's going to go get all the data from our color list inside of SharePoint. Now the last thing I need to do is I need to handle the color, what happens when someone in the color list when they click that delete button. Well, remember, there's an event there called the onRemoveColor event. So I'm going to say that whenever that's called, I want you to call this, or I want you to run the method removeColor. So that's a method that we haven't defined yet. We'll do that right now. So we'll create a new private method called removeColor. So we're having a color that's being passed in, and we know that from the signature of the type that we created a few minutes ago. I'll say const new colors is equal to, and let's just take the old state, take all his colors, and let's run it through a filter and say that for each color, we're only going to return back if the color is not equal to the color that is supposed to be removed. That's going to give me back a subset of all the colors minus the one that was to be removed. And so I'll then just say this set state is equal to colors, the new color collection, just like that. Now when set state runs and the set changes, it will call render again, which will add our color list back, and our color list will then, everything will then run. So now you can see our build succeeded. So let's now give this a shot. So let's come back over here into iTerm so we can see everything is built and we're in good shape. Let's now come over to our hosted workbench. So let's just grab this URL and let's go to _layouts/workbench.aspx and just go into our workbench. And what I'll do is I will then add in our web part. So let's scroll down to the bottom. Here's our React demo web part. So we'll go and select him. Here we've got our 3 different colors. Now to show you that we're actually using real colors now, here, let's go in and let's add in another color, and we'll just use black, or let's use orange. So if I refresh this page, we should see, the one thing we didn't do, I see. So when we refreshed our page, you saw we still had the 3 colors here, and the reason for that is, go back to our code. Remember we had these static colors set? Well, we're still using those static colors. So instead, we need to say this.state.colors. Save our changes. And now once everything rebuilds and we refresh the page, we now should have a dynamic list. There we go. Now we have our 4 picks, even including the misspelled orange. And when I delete something, it should remove it from the collection. It's not removing it from the actual list because we're only removing it from the state collection, so that if we refresh the page, all 4 will come back. But you can see now that I can just very easily make this nice and dynamic. And so in this demo, you saw how to make everything a little more dynamic by adding in additional properties, going and fetching data from an external source, in our case, a SharePoint REST API, by getting data from a SharePoint list. And then finally, we got data from SharePoint and by making things a little more dynamic using the state. In this screencast, you saw how to work with React, Fabric React, in the Office UI Fabric and SharePoint Framework web parts. You got a good overview of what React is and how you would use React inside of a SharePoint Framework web part. And then we looked at the Office UI Fabric and Fabric React. Finally, in the last section, we saw how to work with properties, lifting the state, and how to work with events inside of a SharePoint Framework web part. So I hope you got a lot out of this session, and thank you very much for watching it. We also have a couple links here that you can take a look at for learning more about the SharePoint Framework.